Okay, see, to know the resolving power of a microscope, now imagine you have two objects P and Q separated at a small distance d, meaning we are looking at, let's say, it's the small distance between a mitochondria and nucleus of a cell, something like this, okay, which are very close to each other, but we need to make sure that they are very well resolved. Okay, now to find very well resolved image, first thing is we'll consider the basic thing, that is it is just resolved. Okay, let's say D is the least distance that the two objects are just resolved. Okay, and theta is the semi-vertical angle of the cone. Okay, now what we get here is D is equal to 1.22 lambda divided by 2 sine theta. Okay, so this is basically the, you can say, the just resolved distance. Okay, now here 1.22 appears due to the circular aperture of the objective. Okay, it's because of the lens. Now here, see, if a medium between the objects and the objective lens of the microscope, if it is some other medium, let's say of refractive index mu, then we get D is equal to 1.22 lambda divided by 2 mu into sine theta. Okay, now this gives us the least distance, or it's also called as limit of resolution, correct? Now what is resolving power? Reciprocal of this, right? So 1 by D is equal to 2 mu sine theta divided by 1.22 lambda. So this particular formula gives us the resolving power of a microscope. Okay, now what are the things we have to notice here? Now if the resolving power has to be more, meaning if you look at the cell, if you can distinguish between two objects, then the material medium what is between the objects and the objective lens, that is the value of mu, if that is high, then the resolving power will be greater. This is why we have oil immersion microscopes. We immerse the whole apparatus in an oil so that the resolving power increases. And the resolving power is inversely proportional to lambda, correct? So lesser the value of lambda, more will be the resolving power. This is the reason why we use electron microscopes. Electron microscopes, we can get lambda to be very, very less. That's the reason the electron microscope, the resolving power is extremely high. Okay, so based on these two criteria, the resolving power of a microscope can be changed according to whatever we need. Okay, so the resolving power is given by 1 by D is equal to 2 mu sine theta divided by 1.22 lambda. Okay, so again I'll repeat, the resolving power is directly proportional to the refractive index and inversely proportional to the wavelength of the light used.